today we are going to be talking about a concept that we have done before, but we have called it something else, and it's called linearization. And we're going to kind of play a little bit of a game first to get started. I want you over here to write the word graphs down and underline it, and then I want you to number 1 through 3. I'm going to put my calculator up here on the screen so you can see it. I'm going to ask you, I'm going to make a graph appear on the screen, and I want you to write the equation of that graph for me. Okay? So, let me turn it on. Okay, here comes the first graph. Just write it down. Don't talk about it. Okay, what's the equation of that graph? Number 1, write it down. I didn't say it, I said write it down.
I said say it.
No, I said don't say it. Okay, write it down. What's the equation of that graph? Right there. Okay, this is like a quiz, but it's not going to count like a quiz, so don't talk. Just write. Okay, you ready for the second one? Write it down. What's the equation of that graph? What's the equation? Here comes the third graph. Okay.
How many down is that?
How many down is that? It is 5 tick marks down. Okay. You ready to get the score on your quiz? Okay. So let's, first of all, write down what you wrote. What did you put for number 1? Y equals X. What did you put for number 2? What did you put for number 3? -5. Okay. Actual answers. Okay. Every one of you got a 0 on this quiz. Okay. Here are the actual answers. Let me put this so you can see it. Copy those down. Number 1, y equals sine of x. Write that on your paper. Right here. Number 1, y equals sine of x. Number 2, y equals x cubed minus x. And number 3, y equals 0.25 x squared minus 0.05. You stole my thunder. Okay. How in the world can those equations give you those graphs? My window is what? Super small? Okay. Let's take a look at what my window is. Is it really, what do you think it's going from? Like -100 to 100? Or tiny numbers? Okay, when you zoom out on a sine wave, what does it look like when you zoom out? Looks like this, but would it be a straight line this way? Diagonally? No. Okay, there's the window. It is super zoomed in. Okay, now let me show you this. I'm going to change the window to the standard viewing window. For those of you who may not be seeing what we're talking about, I'm going to zoom 4, which is a pretty good window. There's sine. Okay? Now, do you agree that if I zoomed in at 0, that it would be a diagonal line, like y equals x? Yes? Okay. That one we know what it looks like. X cubed minus x, you may not know what it looks like. Here comes the next one. There's the next one. If you zoom in at 0 here, is it going to be -x? Yes. And let's do the last one. Okay. That one's a parabola. But does it look like it's going down 5? No, because remember that we thought it was y equals -5. That one looks like it's going through 0. Why? Okay, this minus 0.05 means it's really not going through 0, it's going through -0.05, which is so close to 0 on that screen, you can't tell. Does that make sense? Does everybody understand what we're talking about? So, with these curves, linearization is taking the graph and zooming in on a specific point and seeing what line you're going to see. Okay? Now, I'm going to go back and put the window the way it was. Okay, here comes sine's line. Okay, so when you zoom in on sine, you get this line right here. Okay, that is also the tangent line at 0. Think about it. Because when you zoom in, it's going to be pretty much tangent to the point at that specific graph. So, if you are trying to find a value on a graph near that point, the line and the curve are going to be very, very close. So linearization is used to estimate values very close to the point of tangency of the line. Okay? So, yes, sir?
What if the resolution of the screen were a lot better?
A lot better? It would not be perfectly... As soon as I zoom into a certain amount, it will be almost straight. You know, if you could zoom in with microns, it would never be perfectly straight. But with what we have right here, it's going to be straight. Because it's really not straight. It's close, but it's not exactly straight. Does that make sense? Okay. What I'm going to do first is teach you how to take this curve and create this line for all three of those. And actually, you know what? We've already done this before. And it was called finding the equation of a tangent line. Okay? So let's review how to do this. Take that over here. We're going to find the linearization of each of these. Dot, dot. Number 1, we start with the curve y equals sine of x. Yes, my phone's ringing, I know. Sorry. I'm just going to let it go. And it will always give you a point that we're zooming in on. We zoomed in on 0. Because as I zoomed in my screen, it was equidistant on either side from 0. Always around 0. Okay? Now, how did we find the equation of a tangent line before? No, not set it equal to 0. You're close. What are the two pieces of information we need to write the equation of a line? We need a point and a slope, right? So I'm going to write that out to the side. We're going to go at it this way. Okay, what do I know already? I know x is 0. How do I find the y to go with it? Plug it into the original. So the sine of 0 is... No, the sine of 0 is 0. Okay? Now to find the slope, the sine of 0 gives me that. How do I find the slope? Take the derivative, which is correct there. And what do I do with that again? Plug in 0 because it's at 0. So y prime at 0 is the cosine of 0, which is what? 1. Slope goes there. Now we write the equation of the line. Y minus 0 equals 1, parentheses x minus 0. Y minus 0 is y equals 1x. Look, that's the graph that we got, isn't it? So we just algebraically did what we did graphically by zooming in. Okay? Found the equation. Number 2. Y equals x cubed minus x at x equals 0. Same process. Point, slope. What do I know? I know the point is 0. What is the y value that goes with that? 0 again. Now to find the slope, I need to take the derivative, which is 3x squared minus 1. When I plug 0 into here, what do I get? Negative 1. There's my slope. So then write the equation y minus 0 equals negative 1, x minus 0, y equals negative 1x. That's what I got for number 2. Easy stuff? And it's going to stay about this easy, I promise you. Okay. Number 3. Y equals 0.25x squared minus 0.05 at x equals 0. You do it with your table. 3 is going to be close to it. So the point is 0, negative 0.05. The derivative is 0.5x When you plug in 0, you get 0. Y plus 0.05 equals 0. Y equals negative 0.05. There's that one. There's that one. There's that one. Easy enough, right? Y'all agree? Okay. So now we're going to write an official formula for finding what is called a linearization. And what you need to remember, it's the same process as finding the equation of a tangent line. It's just got a new name. At x equals a. It will always give you a point to center the line on. Okay, we're going to kind of build this together. Y minus what? Okay, what do we plug in right here every time we do this?
The y value.
The y value. So in terms of a, that would be f of a. You all agree with that? The y valued a equals. What goes next? The slope. How would we write that in terms of f and a? F prime of a, exactly. That's the slope, because we took the derivative, plugged in a, and then parentheses x minus a goes there. Very good. There's the equation. That's what we're doing. Okay? I have just enough time to do this last example that I did, the same one with first page. Next page. For example, next page for me, maybe not for you. Approximate the square root of 123 by using a linearization. This is was especially very helpful for mathematicians who worked BC, not BC time-wise, but BC before calculators. Okay? When I was in elementary and middle and high school, we didn't have calculators. We got calculators my junior year, and we thought we had died and gone to heaven. All our square roots and trig tables and stuff were in the back of the book. We had to go look everything up. Okay? So actually in elementary school, I was taught there is a method to estimate radicals by hand, like the square root of 8 or the square root of 12, out to 2 or 3 decimal places. And it was, I don't even remember it because it was so yucky. We learned it in the 5th grade. But I'm going to show you with calculus how we can get an estimate of what this is. Can you tell me exactly what this is? No. Okay. Can you tell me what it's close to? It's close to 11. More than 11 or less than 11? It's going to be a little bit more. Okay? But we're going to use a linearization. We're going to find an equation of a line that's really close to the square root curve, and we're going to estimate what this is. Okay? So what we're going to do is we have to come up with a function. Now, because we're wanting the square root of something, we're going to use the plain square root function, square root of x. And we want to choose our x, our a value, to be something close to 123 that I can take the square root of. No, not 11. 11's not close to 123. 121. Okay? I want to go through the same process I just did and find the equation of that tangent line. So, point and slope. Okay, the point is comma 11, because if you plug 121 into here, you get 11. Okay, we're going to slow down a little bit because these numbers are a little bit different. Okay, how do we find the m again? Take the derivative and then plug in 121. So f prime of x equals. You can almost now take the derivative of squares in your sleep, can't you? 1/2 x to the negative 1/2, which means you have 1 over 2 square roots of x. Do you agree with that? Okay. Now, plug in 121. F prime of 121 would be 1 over 2 square roots of 121, which would be 1 over 22. That's your slope. Now write your equation. Now, before you, don't get ahead of me because I'm going to do something a little bit different. Y minus what? 11 equals 1 over 22 parentheses x minus 121. For what we're going to do in a minute, it is best to not distribute the 1 over 22. Just move the 11 over, okay? So I want to write the equation this way. Y equals 1 over 22, x minus 121, plus 11. So if I zoom that curve in at that point, that's the line I would get. And that has it's almost flat because the slope is 1 over 22, up 1 and over 22. I can now use this to estimate the square root of 123 because 123 is x. So what I'm going to do is to estimate the square root of 123. I get y equals 1 over 22, 123 minus 121 plus 11. You substitute 123 in for x because the x and the 123 were in the same spot. Okay, now I just clean it up. 1 over 22, how does the parentheses clean up? It's just 2 plus 11. Y equals 1/22 times 2 would be 2 over 22, which reduces to 1 over 11, plus 11, which means it's 11 and 1/11th without a calculator. So that is approximately the square root of 123. Let's see how close we really are. Okay? So the square root of 123 is that decimal. 11 plus 1/11th is that decimal. Look how close they are. They're pretty close, aren't they? Do you see that? They're right out to 3 decimal places, almost to 4.